Hello, my name is Dr. Dan Wedding, and this is DrWedding, VB18, Timers and Simple State Machines. VB has built-in timers that you can configure. These timers are extremely easy to use. You can effectively control the timer with only two properties. The enabled property will turn the timer on and off. By setting this property to true, the timer is turned on. By setting this property to false, the timer is turned off. An example is shown below. The interval property will determine how often the code inside the timer runs. The interval is in milliseconds, so 500 is half a second, 250 is a quarter of a second, and so on. An example of setting the interval is shown below. If the timer is turned on, it will run the subroutine timer 1 tick after waiting the time assigned to the interval property. For example, if the interval is 500, the code in the subroutine will run every half second. The first program that will be written will be a stopwatch to help you understand how to use the timer. The next program will be a finite state machine or a simple state machine. State machines are mathematical models that mimic how a process works. This model allows you to simulate a process such as an assembly line, a piece of equipment, or the example in this video, a stoplight at an intersection. A video that covers the different types of state machines would take hours, so I'm going to try to compress this into a few minutes. A simple state machine is a process that can be in one state at a time. Something causes the process to move from one state to another, and that could be an input signal or a timer. Assume you have an intersection that has a north-south road and an east-west road. This intersection has 6 finite states that are shown below. Moving from state to state could be caused by a temperature sensor, pressure sensor, button push, or a timer. In the case of a stoplight, a timer will cause the intersection to move from state to state. The best way to learn how to use timers and state machines is through an example. I've opened up a new project named VB18. I'm going to start by adding a timer. You add a timer just like any other object by dragging it onto the form. However, it's different because there's no visual component to a timer. When there's no visual component, Visual Basic will put the object down here at the bottom of the form. When selected, you can change the properties. Next, I'm going to add 2 buttons and a label so that I can generate a stopwatch. Now I'm going to go into the code section. First, I'm going to declare a global variable. This will keep track of the number of seconds on the stopwatch. When the start button is pressed, I'm going to set stop time equal to 0. Next, I'm going to print stop time to the label, and I'm going to make sure it has 2 decimal places. Now, all I need to do is set the parameters for the timer. The interval I'm going to set to 250 so that the timer will run every quarter second. Then all I need to do is turn the timer on. And that's all the timer needs to run, the interval and setting enable to be true. Now, every quarter second, the timer will execute. Now we have to get to the code that executes every quarter of a second. Just like any other object, all I need to do is double-click on the object. This will open up the timer ticked subroutine. That's what runs every quarter of a second. We started stop time at 0. Therefore, every time this subroutine runs, we can add 0.25 to stop time and update the label. Now I'm going to write the program for the pause button. The pause button will pause and restart the stopwatch. I can do this by toggling the enabled property. I can simply type in timer1.enabled is going to equal not timer1.enabled. Therefore, if the enabled is true, not true becomes false. And if it's false, not false will become true. Let's run this program and see what happens. If I start the timer, it's going to count every quarter of a second. I can pause it, restart it, pause it, restart it, pause it, and if I hit start, stop time is going to reset back to 0. If I want to make this a faster timer, I would just change the interval. For example, 100 would be 1/10 of a second. However, I have to update the number that's being displayed on the label also. I'm hoping the stopwatch was very helpful in understanding how the timer works. It's very simple. All you need to do is specify an interval, how often you want the program to update, and enable it. That's it. Next, I'm going to write a program that's going to control the lights at an intersection. This is called a state machine, and it will use a timer. I'm going to go back to the form and start by embedding some objects. Next, I'm going to update the form. Set the size mode of this picture box to zoom, and then add the image of the road. I've added 4 more picture boxes on top of the road, one for each of the lights. They're labeled PB North, PB South, PB East, and PB West. In some cities, stoplights are vertical, up and down, and some are horizontal. You'll notice as I have it set up now, the north and south are vertical, and the east and west are horizontal. I'm going to make all 4 lights horizontal, with the red light next to the yellow line that divides the 2 lanes. I rotated the 2 picture boxes representing the north and south stoplights. However, the lights are still vertical. If I run this program, the lights are still in the wrong orientation. So I need to rotate the image so it matches the rotated picture box. To rotate the image inside the picture box, I'm going to go into Form Load and add these lines. These lines will rotate the image 90, 180, and 270 degrees. These are not being flipped. Let's see how the program runs now. Now the stoplights are perpendicular to each of their lanes, and the red light is on the center divider line. This was not really necessary, but I used this opportunity to cover a little bit more about picture boxes. Let's start working on the state machine. This state machine is going to be controlled by a timer instead of inputs, so I need another timer. I'm also going to need a button that's going to start the state machine. A simple state machine like this will be controlled by an integer. So we can go to the code and add an integer. I'm going to use state to control which state I'm in. When I press the start button, I need to initialize all the values for the state machine. But this is pretty easy. I'm going to set state equal to 1 and initialize timer 2. I set state equal to 1 because I want the state machine to start in state 1. I set the interval of timer 2 to be 1 millisecond and then turned it on by setting enable equal to true. I did this so it would immediately jump to the state machine. Now I need to write the code for the state machine. I'll go back to the form, double click on timer 2, and I can write my state machine code inside timer 2 tick. The easiest type of state machine is an if block inside of a timer. Each if statement corresponds to one state in the state machine. For example, this particular state machine has 6 states. When all 4 lights are red, when the north-south is green, when the north-south changes to yellow, when all 4 go red again, when east-west goes green, and when east-west goes yellow. Then we return back to state 1 where all 4 lights are red. Each one of these if statements is one state in the state machine. Each one of these states can be broken into 2 parts. The first part is, what do you do when you enter the state? And the second half is, what do you do when you exit the state? When entering the state, I do all the tasks that that state requires. State 1 sets all 4 lights to red and then rotates the ones that need to be rotated. I combine the 2 lines using the colon to save space on the screen. These are the tasks that you need to do when entering the state. Next, we have to determine what we're going to do when we exit the state. Exiting the state requires you to tell it what state is the next state you're going to. At the end of state 1, we know that the next step is state 2. At the end of state 2, the next step is state 3, and so on. When we get down to state 6, state 1 is the next state, because this is going to repeat. Lastly, we're going to need to know how long we're going to wait before we come back here and change the state. Therefore, I will change timer interval inside of each one of these states. In the real world, these times would be in the minutes, but I don't want to wait that long. Therefore, I'm going to use short fictitious times to hold the lights green, yellow, and red. I've added in the timer 2 intervals for each of the states. For example, at the end of state 1, I've added timer 2 interval to be 1000 milliseconds. It's important to understand this is not holding the code at this line for 1 second before moving on. This command is telling the computer to come back to this subroutine in 1000 milliseconds. At that point, state will be equal to 2, and the second if statement will be executed. This pattern will repeat for state 3, state 4, state 5, state 6, and then repeat back to state 1. Let's run the program and see what happens. When we start the state machine, 2 lights go green, 2 lights go yellow, all 4 go red, 2 go green, 2 go yellow, and all 4 go red. This process will run forever. That makes sense. You don't want your stoplights just stopping randomly. State machines can be dynamic, meaning you can change the program in them. For example, this light can be converted to a 4-way red blinking light in the case of an emergency, or 2 lights could be made yellow and 2 lights could be made red. Let's demonstrate this. First, I'm going to minimize some of the subroutines to make some room in the code section. Now I'm going to update the form. I've added 3 more timers and 3 more buttons. Each button will represent a different state machine. However, they're all going to be using the same images, just in a different way. Let's start with the 4-way stop. This will have all 4 lights blinking red and off, red and off. Therefore, I had to add 1 more image to my resources, one that had the lights off. The first one will be a 4-way stop. This will just have all 4 red lights blinking on and off. We can set up the state machine like we did before. State will equal 1, the starting point. We'll set the timer interval to be 1, so we'll jump to the state machine code immediately. And then we'll enable this timer. This looks like the state machine button that we set up before. However, if you have multiple state machines running, we have an extra step. We have to make sure the other state machines are turned off before we start this one. That's really the major difference with respect to the buttons. I'm also going to have to disable the timers in this button up here. Let's go back to the 4-way stop, double click on its timer, and start writing the routine. In this state machine, there are only 2 states. Therefore, the if block will only have 2 if statements. Just like before, the first half of this if statement is all of the tasks that need to be performed when entering the state. The second half of these if statements is what we want to have happen when we return to this subroutine. We can repeat this process 2 more times. Once for north-south stop, where north and south will be blinking red and east and west will be blinking yellow. And also east-west stop, where east and west will be red and north and south will be yellow. This is the state machine that sets north-south at stop and east-west at yield. And here's the last state machine that makes east-west stop and north-south yield. Let's run this program and see what happens. We can run this intersection in normal mode. We can turn this into a 4-way stop. We can turn it into a north-south stop. And we can turn it into an east-west stop. I hope this video was helpful in learning how to use a timer and what a state machine is and how a timer can be used to generate one. In review, VB has built-in timers that you can configure. You can effectively control the timer with only 2 properties. The enabled property will turn the timer on and off. The interval property will determine how often the code inside the timer runs. The interval is in milliseconds. If the timer is turned on, it will run the subroutine timer 1 tick after waiting the time assigned to the interval property. State machines are mathematical models that mimic how a process works. A simple state machine is a process that can be in one state at a time, as demonstrated with the stoplight code. A button can configure the state machine parameters and then turn on a timer. Inside the timer code is an if block, where each if statement is one state. Each if statement has 2 parts. The first part is running all the tasks that the state needs to do, such as assigning images to picture boxes, sending signals to hardware, and so on. The second part is what needs to be configured to leave the state, such as what is the next state in the state machine, and how long should the program wait before returning to the subroutine. If you find these videos useful, please like and subscribe. It is the only way I can continue to make these videos.